Hey guys, welcome back. Today we're going to talk about how to find the average of something that is continuous. So, let's start by thinking like if you wanted to find your average test score. What you would do. You would add up all the scores and divide by the number of scores, right? You'd add them all up and divide by the number of scores. That's an average. Well, what do you do if the thing you're trying to find the average of is continuously changing? Let's, for example, make up some function that, let's say this function that I have represents the temperature in my classroom, blah, 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 blah. This is an equation. I don't really care. But it represents the temperature in my classroom, at any given time. So first I'd ask, is the temperature in my classroom continuous? Is there always a temperature in this classroom? Yes. Okay. Well, now let's say I want to know what is the average temperature in my classroom during my school day. So I'd have to take, assuming this was some function I managed to write an equation for it, okay? To find the average temperature, I would have to add up all the temperatures. Well, what's another way to add when there's a bunch of numbers? Integrate. I'd have to add up all those temperatures, and another way to add is to integrate, okay? And I would add them all up from the beginning of my day to the end of my day, times 0, times 8 hours, we're assuming. That adds up all of those temperatures. Now I have to divide by the number of temperatures, which we do by doing 8 minus 0. That's how you find the average temperature in my room. Okay, so think of this as adding up all of those continuous temperatures and dividing by the number of temperatures, kind of. Okay, so here's an example. Well, let me show you what the actual theorem looks like. So here's the mean value theorem or the average value theorem. Okay, as long as F is continuous, something like temperatures, then the average of that thing is adding them all up and dividing by the number of numbers, subtracting those bounds, okay? That is the average value, and it's real easy. Just be careful not to confuse it with average rate of change. Remember, average rate of change is your algebra 1 slope, f of b minus f of a all over b minus a. So don't confuse it with an estimated derivative. This is finding the average of something that they give you an equation for, okay? So that's the average value theorem. Here's an application of it. Okay, usually these are calculator problems, by the way. All right, so they give me an equation that represents air pollution, level of air pollution. But then they ask for the average level of air pollution. Okay, that's typical right there. Just got to see that word average and make sure it's not average rate of change. It's the average of something. Okay, so as soon as you see it's the average of something, you're going to integrate that thing from 10 to 20 and divide by the number of numbers, 1 over 20 minus 10. Now keep in mind what you're finding is the average of whatever that thing is defined to be. So this would be the average air pollution, okay? And then you just put that in your calculator and put it all in your calculator at one time. 1/10, math 9, and you don't have to write any other work on your paper because it's all calculator work, okay? So go ahead, hit pause, put that in your calculator. Okay, so your answer should have been 0.238. And again, make sure you understand what you found. That is the average level of air pollution. Okay, here's another one. Okay. So they made up this crazy equation, whatever. Maybe I don't know how they came up with it. So this S of t represents speed on the Boston Expressway. Okay, whatever. But they want the average speed, not the average rate of change. They defined this to be speed, and they want the average of that thing. So again, it's just integrate from 5 to 7 and divide by the number of numbers, 1 over 7 minus 5, which is 2. Okay, and that will get the average of whatever this is defined to be, the average speed. Okay, and it's all calculator work. Don't have to do anything else. I don't really care about the answer, so I'm going to move on. Oops, what happened here? What did I do? Oh, this is a new one. Okay, now we're at an airport. Okay, let's actually do this one because I want to show you what else could happen. Another question that they could ask, okay? So set it up, write it down, hit pause, get your answer in your calculator. I'm going to do the same, so I'll be right back. Okay, so hopefully you did okay putting that in your calculator. Make sure you practice it. Also, by the way, this gives me a chance to remind you, anytime there's trig involved, make sure your calculator is in radian mode. They don't have to tell you that. They're not going to tell you that. You have to know that. Every time you reset your calculator and clear the memory, it automatically goes to radian mode, so it shouldn't be anything you have to change. But if you are in degree mode, you will get the wrong answers. Okay, so hopefully you got that. That's the average temperature between 1 and 4. All right, now, what if they change this question and they say not what is the average temperature, but instead they say when will the airport reach that average temperature? When will the airport reach its average? Okay, that's often asked as well. Think about that. How would you do that? Okay, now the question is when, so you need to solve for the t. So basically, you're going to take this equation and you're going to say, oh, when will it reach that temperature? So you're going to plug this in for the y coordinate, basically. So you would then take 47.657, set it equal to this. Oops. Sine of 1/3 t minus 2 plus 60. And you would have to solve that, okay? So sometimes they ask you, when will it actually reach that? Now, I want to actually do this with you because this is some pretty ugly numbers. So what do you do when you have ugly numbers like this, okay? First of all, make sure you understand why we did this. They asked for when will it reach that average. Okay, now, how do you solve ugly equations like this? Take the equation and set it equal to 0. So move this to the other side, okay, so that you have it set equal to 0. Then you're going to graph all of this and look for when it equals 0 using your calculator. Okay, so I want to make sure we do that right now. So I've set it equal to 0, but by the way, I'm rounding this number on my paper, but in reality, I'm keeping that in my calculator. You don't want to round in the middle of the problem. You want to make sure you round at the end. Okay, so now in order to solve this, we're going to graph this and look for when it has a height of 0. And use your calculator. Make your calculator give you that answer. Don't just hit trace, okay? So hit pause and put that into your calculator. Y equals 14 sine of, it's going to take you a little while to put all that in there. Okay, so I graphed it. By the way, my calculator wouldn't let me hit the answer function within the graph, so I had to write down all these digits so that I didn't round too much too soon, and I typed in all those numbers. Okay, when I graph it, it oddly looks a lot like a parabola, by the way. Okay, we're looking for where it has a height of 0, and there are 2 places, but one of them's negative, and you can't have a negative time. So, by the way, just to make sure your graph looks the same as mine, it looks kind of a little like this, and we're going to be looking for this point right here, okay? So, remember, use your calculator's function to find the 0. So you're going to hit second calc, which is above trace, and then actually use your calculator to get the 0 and round to 3 digits, nearest thousandth. So I hit second calc. I want the 0, option 2. You have to get to the left of the point you're trying to find and hit enter. Then get to the right of the point you're trying to find, hit enter, and hit enter again. Okay, round to the nearest thousandth, I get t of 2.762. Okay? So that is honestly a very typical AP type question. Okay, I wanted to practice all those rounding issues and stuff like that. Okay, now what if they asked you to round this to the nearest whole hour? What time frame does that represent? Okay, reread the question and put this back into common sense in the real world now. Since time is represented as hours past midnight, this would be almost 3 a.m. Okay? All right, so let's see if I have another example. Okay, I'm not going to do all this because I know you don't want to be listening to this forever, but this is an actual AP question. I want to just run through it real quick with you. We're not going to actually do it, though. So make sure whenever they give you a table, make sure you read carefully. Make sure you know what it actually stands for, okay? This one is L of T, and it stands for people. Read it again. Make sure you actually have a real-world understanding of what the situation is. Okay, so L of t is the number of people waiting in line. Okay, so there's this L of t, this represents the number of people waiting in line. Okay, part A, estimate the rate at which the number of people waiting in line is changing. Okay, that's just to review. To find the rate that it's changing, that's an estimated derivative at 5.5. Well, 5.5 isn't here, but we're going to use the two numbers surrounding it. So we would do the algebra 1 slope, and it would be 150 minus 126 over 7 minus 4 people per hour. Okay, that's just a review. Now read part B. Okay, you actually got this question from me in the past. We had it on a worksheet when we did trapezoid rules. Okay, so sometimes you have to do a trapezoid. Estimate the average number of people. By the way, it's just the first 4 hours. Okay, well, this is number of people. So to get the average in first 4 hours, it'll be the total number of people in the first 4 hours divided by the number of people. This would give me the average number of people. Okay, but L of t, since it's not an equation, we're going to estimate this integral by doing a trapezoid rule with 3 subdivisions. Okay, so this actual integral right here is going to require us to do a trapezoid rule. So let me review that with you. I had to rewrite it. We didn't have much space here. So leave that 1/4 in your work so you don't forget it. And now I'm going to do the integral using my trapezoid rule with just these numbers. It's 1/2 the height, which is 1, times the sum of the bases, 120 plus 156, plus the next trapezoid would be from 1 to 3. So 1/2, the height is 2, subtracting the 1 and 3, times 156 plus 176. And then the last one, using the 3 and 4, 1/2 of 1 times 176 plus 126. Okay, just wanted to review that. We don't need to get the answer, but I just wanted to show you how this would look on an AP question. Okay, by the way, if you want to read ahead to part D, that's also something we just did on our last test. Okay, last one. This one I don't, again, want to actually do it because it's in your homework, but I want to discuss it, okay? I give you a graph, and I want you to find the average using a midpoint rule. Okay, average value, average height is really what this is this time. So my average would be the total from 0 to 6 of f divided by 6. Okay, well, now to find this actual, I don't know if this is time or f of x or what that is, but now to find the integral, we're going to use a midpoint rule. So it's 1/6 of, all right, midpoint rule of 3 subdivisions. So turn this into 3 rectangles, okay? But what is the height of those rectangles? It's going to be the height at the midpoint. So we want the height here for the first one. And at 3, we're going to want the height here. And at 5, we'll want the height here. Okay, so let me redraw that. These are our rectangles. We're using the height at the midpoint. Okay, can you see that? So now find the area of all those rectangles. Okay, so it's going to be 2 times 4 for the first one. The next one is going to be 2 times whatever the height is, 3. And 5 times 2. Okay, so whatever that is, I just wanted to remind you how to do the midpoint rule. Okay, so last, I thought I was done, but I'm not. If they ask for the average value on this or on an equation, okay, still do the same thing. Just, by rote memorization, go ahead and do your average value formula, okay? So it's the integral from 0 to 3 divided by 3, and that will give you the average, which is, when it's an equation like this, you're getting the average height, okay? Now, if you had to integrate this by hand, you should practice that, I suppose. So integrate by hand. Most of them are going to be calculator questions, though. So we would integrate by hand. This is all out of order. Hold on. Let me hit pause. Okay, in an effort to speed up this video, I'm going to just assume you can integrate that by hand. And we find that the average height is 1, okay? So if the average height is 1, now reread the question. Find the average value. Done. It's 1. Now, if they say, at what point or points in the interval does the function assume its average value? Now you would let f of x be 1 and solve for x. Okay, just in case, I just wanted to make sure you understood that. So set it equal to 1, do your algebra, blah, blah, blah. You get 2 answers, but only one of them is in the interval from 0 to 3. Okay, now I'm done. I swear this is easy homework. I just wanted to also take the chance to review like some AP type questions. Most of your homework is going to be done with your calculator, and you just have to show the setup. Good luck, people. Hope you're doing well. Bye.